Hello everyone, welcome back to Nexgen Academy. Today we are going to discuss an important topic called logarithm, which is very important for many chapters. It can be electrochemistry, kinetics, or thermodynamics, equilibrium. So many chapters you need it even in physics also. But the problem is the content available online is very less and the shortcuts are that won't work every time. So first you spend some quality time in understanding everything from the beginning to the last. So in this session we will discuss completely logarithm, how to calculate the logarithm for different numbers, fractions, and 1, 2, 3, 4 digit numbers also, and left and right. Let us play with that. Okay, let's see what is log and how to calculate it. So before going to that, certain terms you need it. First I'll teach you that, then we go for the log. Okay, so first I'll give you the definition, then the terms required and everything, and certain formulas are required. First I'll discuss all that, then we go for applications. Okay, so without wasting time, let us see what is log. Log is something like, for example, if you wanted to write 100 as 10 to the power of something x, 100 you wanted to represent as 10 to the power of some x exponent. So how to write it? What is x here? So here 100 is nothing but what? It's easy. 10 to the power of 2. 10 to the power of 2 is nothing but what? 100. Yes. If you wanted to write 1000 as 10 to the power of some x, what is x here? X is here, x is 3. Let us see, 10,000 is there. How will you write 10,000 as 10 to the power of x? What is x here? X is equals to 4. Clear, right? The same way, if you wanted to write 2 as 10 to the power of some x, then how to find it? So that is what the logarithm logic. So here log 100 is equals to, we say 2. So base 10 we say, log 100 base 10 is equals to 2 we say. Here log 1000 is equals to 3. Log 10,000 is equals to 4. Same way, log 2 is equals to what? 0.301. That means 10 to the power of, therefore 10 to the power of 0.301 is 2. So try to understand the interlink between one other. Okay, so in the next slide we'll see what is meant by this. A is equals to 10 to the power of x. So if you wanted to know the ex, if you wanted to know the x, so log A is equals to, we will get x. That means A is written as 10 to the power of something. Clear, right? So at the same time, anti-log of x is equals to A, we write it. What does it indicate? Let us see. 10 to the power of some x is equals to 2, I told you. So here what is the log here? Log 2 is equals to nothing but what? That x. Are you getting what I'm saying? So how to write 10 to the power of some x as 2? Or 10 to the power of what? What is that x to get the 2? See, for that we need to do logarithm, as I told you. Log 2 base 10 is equals to 0.301 we say, or anti-log 0.301 is equals to 2, or 10 to the power of 0.301 is equals to 2. Anti-log nothing but what? 10 to the power of something. Clear, right? So the same logic which we have seen in the previous slide. See, let us see another example. Okay, so multiple examples we can write it like the same way, but before going to that, so how to calculate the log and everything, we will see that. And first you should know what is scientific notation. What is scientific notation? Any number is given to you, how to write in scientific notation, I'll tell you, then we go for that. So scientific notation, for example, 1234 is given to you. 1234, 4-digit number. So how to write it? 1234 can be written as what? 1, 2, 3, 4 into 10 to the power of 0. Anything to the power of 0 is what? 1. 1 into 1234 is what? 1, 2, 3, 4 only. Yes, you can write 123.4 into 10 to the power of 1. Can't able to write it? Yes, we can write it. And 12.34 into 10 to the power of 2 also we can write it. Even 1.234 into 10 to the power of 3 we can write it. These are all different ways to represent 1234. Am I right or wrong? Yes, here 4 different ways I have represented. This is called scientific notation. What does it indicates is scientific notation is, see, whatever the digit, whatever the number is given to you, first we have to see, you should know what is non-zero and zero. So except 0, 0, 1 to 9, we call them as what, non-zeros. So always we have to keep the decimal point after the first non-zero and write into 10 to the power of some n. Clear? And here n is what? 3. So 1234 is written as what? 1.234 into 10 to the power of 3. Clear, right? So the same thing here, if it is given as 2026, how to write it? 2.026 into 10 to the power of how many points? Earlier point was here 1, 2, 3 positions we have shifted. Like this we have to write it. Any number is given to you, scientific notation, writing method of writing number in scientific notation is this. After the first non-zero, we have to write it. So now you know how to write the scientific notation. Say yes or no? Yes. So let us see how to write the logarithm also. So any value is given to you. Let us say a question is given log 1234. Let us take the same example. There are two parts in the logarithm. One is characteristic, the other one is mantissa. So characteristic, and the second part is mantissa. So how to calculate, how to find the characteristic and mantissa, let us see. So characteristic is nothing but, in the scientific notation we have taken the power, right? That is what characteristic. See 1234, as I told you how to write 1234, 1.234 into 10 to the power of 3 we discussed. So this is called characteristic. Yes, characteristic is this. What is mantissa? So mantissa is simple. Any number, see, 1000 we had 3, right? 1000 we had 3. 10 to the power of 3 we have written. But this is 1234, right? So 1234 means what? The 234 is the right, that extra. So what you will get it is, if you take the logarithm, you will get a 3 point some x value, you will get it. So this whatever the value is there, that after the decimal point, whatever the value you will get it, that we call it as what? Mantissa. So characteristic plus mantissa, 3 point, let us say 3.0913. See here, actually if you solve it, you will get it 3.0913, you will get it. So this characteristic is 3, mantissa is what? 0.0913. After point 0913 is the right, that is called mantissa. So here round of value, whatever the integer value is there before the decimal place, we can directly get it, but the fraction we cannot get it directly. So for that reason only we need the help of logarithm table. So characteristic we have found it, but mantissa, how to find the mantissa? As I told you, 3.0913 is the answer for log 1234. So this 3 we can directly write it based on the scientific notation. The power whatever we have written is characteristic. But how to find the 0.0913, whatever is there after the decimal point, that we need logarithm table. Yes, come back to the discussion. So here logarithm table, what we have, see this I have direct. Here logarithm table I have taken, this is I have downloaded. Okay, so here whatever the number you wanted to find it, we have this one. See, if you take the logarithm table will have 4 pages actually. First 2 is logarithm, remaining 2 are anti-logarithm. So logarithm table, first page I have opened in this. So what is the observation here? Tell me. Here number, 2-digit number, it has started from 10 and ended with 99, means 2-digit numbers will be there in that. And here what is there? This is called 0 to 9, whatever is there. These columns we call them as what? A main column we say. What is it? A main column we say. And the after 9, whatever 1 to 9 are there, this is called mean difference column. Mean difference column we say. Mean difference column, and this extreme left side is the 2-digit number is there in this column, and this is main column, and this is mean difference column we say. Yes, how to use this table? Let us see this. See, for example, our target is what? To find 1234, right? Forget about the decimal point. Now you don't bother about the decimal point. We wanted to calculate the mantissa. Forget about the decimal point position. Clear, right? Yes. First two digits. Where are the first two digits? These two digits. These two digits. We have to find this. What is that? 12 under. Where is 12? This is 12 under third digit. What is third digit? 3. So where is 3? 12 under 3. 3 you find it here. 12 under 3. What is there here? Carefully observe it. So 12 under 3. What we got it? 0899. Yes. Next, fourth digit. Fourth digit, where to find it? We have to find it from the mean difference. 12 mean difference for, what is this? Look at this. 14. Add this for this number. Okay, so what is the total? 0899. What will get it? 0913 will get it. So this is the value you are getting. But what I told you, this mantissa always after decimal point something, right? Then to get that value, what we have to do? Shortcut is always 0.0913. Whatever the number you get it here, that for that you add 0. That is the simple shortcut, and simply you'll get the answer without any confusion. Come back to the original discussion. So as I told you, why I am adding 0. See, 12 under 3 and 4, when you added mean difference 4, what you got it? 0913 you got it. So what I said, 0.0913, I told you to take it as characteristic, sorry, mantissa. Why 3.0913 we should get it, right? Why? It is more than 1000, less than 10,000. 3 point something is there. To get that one, what to do? 0 point only have to take it. So earlier what we got it? 0.0913. Now add them, 3.0913. This is what? The answer. Clear, right? How simple it is. Yes, let us see some other example also. Log 1234 is what? 3.0913. Yes, we take another value, log 2026. I wanted to calculate it. So how to calculate it? Let us see. 2026. How to write it? 2026 can be written as what? 2.026 into 10 to the power of 3. Clear, right? Because earlier decimal point is here. 1, 2, 3 positions you have shifted. That's why 2026 can be written as what? 2.026 into 10 to the power of 3. So what is the characteristic here? 3. 3 you take it. How to find the mantissa? Again go back to the table. Under 2. 20 under 2. What is there here? 3054. 20 under 2 is what? 3054. Next, mean difference. This is mean difference, right? So mean difference 6. This is that. Now verify. 13. What is that? 13, you add it. So 3054 plus 13, 7603. What I told you? 3067 you are getting. So since it is mantissa, what to do? You add 0. That's it. 0.3067 is your mantissa. Come back to the discussion. 0.3067. What is the answer? 3.3067. Clear, right? So this is the answer. What is log 2026? 3.3067. Okay. Next, what we have to do? Any number is given to you, the same method we have to follow. For example, log 123.4 is given to you. Can't able to do it now. Fatafat do it. So 123.4 can be written as what? 1.23 into 10 to the power of 2. Yes or no? This is characteristic. Characteristic is what? 2. Mantissa. Mantissa is what? Same method, right? Mantissa method is same. So same thing. What is that? Under 1, 2. 1234 only, right? Digits are same. Here, forget about the decimal point position. So 12 under 3 mean difference 4, you take it. 12 under 3 mean difference 4. What is that? 0899 mean difference 4. Mean difference of 4 in the sense what? 14, like earlier only. Same value you will get it. What you will get it is 0913. Since it is Mantissa 0.0913, we have to take it. Clear, right? So come back to the original discussion. So 0.0913. Answer is what? 2.0913. Is that clear? Let us say log, if question is given like this, log 12.34 is given to you. How to solve it? Tell me. So 12.34 can be written as what? 12.34, 1.234 into 10 to the power of 1. Characteristic is 1. Then characteristic is 1. Mantissa like earlier only 0.0913. Shortcut is what? 1.0913. Conclusion is this. For example, conclusion is what? What is happening here? So Mantissa is not changing. In all the situations, Mantissa is not changing, but characteristic is changing because so the decimal point position, right? Decimal point position is changing. See what I told you, log 1234 value 3.0913 we got it. Log 123.4 2.0913 we got it. Log 12.34 when we have solved it 0913 we got it. So here observe this. So Mantissa is same, characteristic is changing, that's it. Remaining all are same. Clear, right? This is the logic. So any number is given to you, you can solve it in this particular fashion. Clear, right? One fraction also let us take it. So for example, log 0.1234 is given to you. How to solve it? So same logic. How to solve this one? Tell me. Here 0.1234. When whatever the number is given, convert into scientific notation. Scientific notation means what? See, this is 0. First decimal point should be there after first non-zero, means in between 1 and 2. So write it in scientific notation 1.234 into 10 to the power of -1. This -1 is what? Characteristic. Yes, characteristic. And Mantissa as usual 1234 only we have to take it. Forget about the decimal point position. 12 under 3. Mantissa, what is that? Mean difference 4. What will get it? 0.0913 will get it. So you subtract it 1 minus 0.0913. Clear, right? 0.9087. What is that? Minus 0.9087. Verify it. Clear, right? So conclusion is what? This is what? Minus value, this is plus value, right? Be careful while calculating. So this way you can calculate any number. Okay. So let us come back to the original discussion. So what is this? So logarithm of any number, if you wanted to calculate it, two parts will be there. One is characteristic, other one is Mantissa. Characteristic is identified by converting into scientific notation. Whatever the power you are writing in scientific notation, that is characteristic. Mantissa, we use the logarithm table to find the Mantissa. So Mantissa is the fraction which is there after the what? Decimal point. So different numbers irrespective of the number, as I told you, irrespective of the number. So first two digits under third digit in main column, and mean difference, if fourth digit is there, that is under mean difference. We have to find it. Clear, right? It's how simple it is. So now let us find the anti-logarithm. As I told you, logarithm and anti-logarithm are what? Opposite to one another. So as I told you, 2 is equals to 10 to the power of some x. So from the formula, log 2 is equals to, as I told you, x, and anti-log of x. If you do anti-log of x, you will get 2. That means here the what? Log 2 value we know, right? Log 2 is equals to 0.301. We write it. What does it indicate? Tell me. So anti-log of 0.301 is 2. So reverse relation, that is anti-log of 0.301 is 2. Okay. So let us see how to find the anti-log of 0.301. Anti-log of 0.301. Anti-log, as I told you, 10 to the power of 0.301 is anti-log. How to find that? Let us see. Here, anti-log, same like log table, anti-log also we have a table. Let us see that also. See, this is anti-log table. Okay. So how to find the anti-log value of 0.3010? Same thing like log table. You have, see, 0. It started from 0.01, 0.02, 0.03 up to 0.99. You will be there, and the same thing like a main column will be there here. A main column will be there, and this is what a mean difference. This is, as I told you earlier, mean difference. This is main column and mean difference column, and this is number column only. So which is started with 0, nothing but what is after that 0.01, 0.02, 0.099 up to 0.099 we have. So let us come back to the original discussion. Our target is to calculate 0.301, right? So how to find 3010 we written, but it is negligible only. So first what to do is, first 0.30, where is 0.30? That we need to find it. Now we have to find anti-logarithm, right, for 0.3010. So as like earlier, same thing we have to find it here, 0.30. So 0, 1, 2, 3, 4 will be there in that. So here 0, this is 0 column, 1, 2, 3, 4 will be there. So this is 1. So what is there? 0.30 under 1 is what? 2000. Okay. Next, another 0 is that there is no 0 in, what is that? A mean difference. So the value is what? 2000 you are getting. Here the logic is important. What you are getting here? 2000 you are getting. So here you should not take 2000 as such. So here what is this? You remember characteristic. Whenever you are writing characteristic, what we have to, what we have taken, characteristic is what? Left side one, and right side one is for fractions, we have told, right? So same thing here, 0 point something you are finding, right? This is for the fraction you are finding. So fraction in the sense, in the simple shortcut, if 0 is there, then after one decimal point you have to keep it. If 1 is there, characteristic 1 is there, then what we have to do? 20 we need to make it. If 2 is there, what we do? 3, right? If 4 is there, we should keep it decimal point here. So here 0 is there, that's why we have to keep decimal point after 2. Clear, right? So this 2 you have to take it for the calculation purpose. So here what is the answer? 2 only. So or otherwise exactly you got this value, right? You have to write it. So try to understand the logic here. Whatever the value you have calculated, you got it like this. This is not the answer what I am saying. So 0 point you have found it for 0.3010, right? So here 0 point something means what? After one decimal point, right? Characteristic, how to write it? So 2 is there. How to write this one? Tell me. 2 into 10 to the power of 0, right? So that means for 0 you are writing for single digit number, right? That's why we have to take it. Let us take another example of the same thing, anti-log. So if you wanted to find anti-log of 0.6021, if you wanted to find it, let us see how to find it. So anti-log, as I told you, anti-log is nothing but what? 10 to the power of 0.6021. Okay, so let us see in this table what is there in this here. See this 0.6021. We wanted to find it. So for 0.60, first two digits under, say this is what? 0, 1 and 2. What is there here? 3999. So 3999, and the mean difference is 1. What is mean difference? This is 1, right? So what is that? Mean difference 1. So add it. 3999 plus 1 is what? 4000. Clear, right? So as I told you, whenever you are calculating this value for a fraction, right? That's why what to do? 0 point is there. That means after one digit you have to keep the point. So overall answer is what? 4. So answer is 4000. Clear, right? So you remember log 4 value is what? Obviously this. Clear, right? So different values you can write it like this. Any number is given to you, you can do it. Let us take one more example which is having negative anti-logarithm value. That is important actually. So look at this. Many people get confusion here. Anti-log of minus 0.3010. If this value is given to you, how to do it? Let us see. Anti-log, as I told you, anti-log is what? 10 to the power of minus 0.3010. Clear, right? So 10 to the power of minus means what? Anti-log table, you check it, there is no minus values, but here value is given as minus. Then how to write it? So something, can we rewrite this one like in a positive manner or positive number? Let us see. This is minus 0 point something is the right. You take the nearest integer. So what is that? Minus 1. You take it minus 1. You subtract this value from that. So 9 9. So 6 0 point minus will be the right. So can we write like this value like this? Can we write this value like this? 0.699. Look at that. See that? 10 to the power of minus 0.301. I have written as what this? See, minus 1 plus 0.699. Nothing but what this one only, right? That means this and this both are having the same value. See this? Earlier, 10 to the power of minus value only there. Now, I have positive value. Whenever positive value is there, you can do it, right? Let us go to the original discussion. Means we will go for the table. So what is there here? 0.6999. So earlier we have calculated, right? 0.69 under 9. 0.69 under 9 means what is there here? This is 9 only, right? 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Right? So what is the value here? 5000. As I told you, 5000 is there since it is 0 point something, right? So you have to keep the decimal point here 5 only. So come back to the discussion. So here 10 to the power of minus 1 into 5. This value is 5. So 5 into 10 to the power of minus 1 means what? 0.5. This is the answer. So any value is given to you, you have to write it like this. Is this clear? So whatever the number is given, positive number, negative number, anything you can do it in this fashion. Clear, right? Let us see one more example of this one. See negative value. Anti-log of. Calculate the anti-log of minus 1.234 is given to you. How to do it? Anti-log means for 10 to the power of minus 1.234. Can we able to separate this one? Yes, we can separate it. How to do it? So here 1 is the right, minus 1. We can write it like this. Am I right or not? Check it. Minus 1 into 10 to the power of minus 0.234. Right? Both are same only. So this value I have written like this. But the problem is what? This is having a negative sign. This is having negative sign. That's why what should I do? I should do something. So here again 1 minus, you do that value 2, 3, 4. Clear, right? So 0.766 minus 1 into 10 to the power of 0.766. Clear, right? So this is 10 to the power of minus 1. Minus 1 is what? Minus 2 into 10 to the power of 0.766. Now use the anti-log table to calculate this value 0.766. So 0.76. What is that? 0.76 under 6. 1, 2, 3, 4, 5, 6. So this is under 6. What is that? 5, 8, 5, 8, 2, 1. Clear, right? There is no other digit to take the mean difference. Obviously, what we can write? 5.821. Come back to the previous discussion. What is that? 10 to the power of minus 2 into 5.821. Clear, right? 5.821. Clear, right? So conclusion is what? 5.821 into 10 to the power of minus 2 is the answer. What is the antilog of this one? Antilog of 10 to the power of what? Antilog of minus 1.234 is what? 5.821 into 10 to the power of minus 2. Hope you enjoyed the video, right? So now we have seen logarithm, antilogarithm, log to antilog, antilog to log also we can do it. Any value is given to you, be careful, correctly you do it. The decimal points you may do the mistake. So take multiple examples, keep on revising, you'll become what? Master in that. Clear, right? It's not like a one-day discussion. So keep practicing multiple times, you'll get the perfection. If you have any doubt, please comment in the below section and we will get back to you if you have any doubt in it. Clear, right? Thank you for following Nexgen Academy. This is Gopichand signing off.